Single-turn coil. In this exercise, you will learn about the terms used in armature windings and types of armature windings. The schematic diagram of a single-turn coil is shown. The loop that is starting from commutator segment 1 and ending at commutator segment 2 is termed as coil. Referring to figure PQRS is termed as a coil. A coil consists of two coil sides or conductors. Referring to figure, PQ is a coil side and RS is another coil side. In a single-turn coil, coil side is same as conductor. Coil side. Here, PQ and RS are two conductors along with their end connections connected to their commutator segments at 1 and 2 respectively. Multi-turn coil. A coil can have many turns. The schematic diagram of a multi-turn coil is shown. In multi-turn coil, each coil side consists of multiple conductors. Referring to figure, each coil side has 3 conductors. The group of conductors is tied together with tape as a unit and is placed in the armature slot. Slots are used to house the armature conductors. Referring to figure, PQ and RS are called as coil sides. Pole pitch. Pole pitch is defined as the distance between two adjacent poles. Pole pitch is measured in terms of slots or coil sides. Pole pitch can be expressed as the ratio of number of slots in the stator to the number of poles. Referring to figure, there are 24 armature slots and 4 poles. Hence, pole pitch, or PP, equals 24 divided by 4, which equals 6. Coil pitch is defined as the distance measured between two sides of a coil in terms of armature conductors. It is denoted as PC. Referring to figure, coil pitch is the difference between coil sides 1 and 5, and hence coil pitch, PC, equals 4. Back pitch. Back pitch can be defined as the distance between two sides of a coil, measured in coil sides, at the back end of armature. It is denoted as PB. Referring to figure, back pitch, PB, is the difference between coil side 8 and 1, and hence, back pitch, PB, equals 7. Front pitch. Front pitch can be defined as the distance between the coil sides connected to the commutator. It is measured in coil sides at the front end of armature. It is denoted as PF. Referring to the figure, front pitch, PF, is the difference between coil sides 3 and 8, and hence front pitch, PF, equals 5. Resultant pitch. Resultant pitch is defined as the distance between the beginning of one coil and the beginning of the next coil to which it is connected. It is denoted as PR. Referring to figure, resultant pitch, PR, is the difference between coil sides 1 and 3, and hence resultant pitch, PR, equals 2. Types of windings. Single-layer winding. The schematic diagram of a single-layer winding is shown. In single-layer winding, number of coil sides is equal to half of the number of slots. Two-layer winding. The schematic diagram of a two-layer winding is shown. In two-layer winding, number of coils is equal to the number of slots. Wave winding. Armatures are wound with either lap windings or wave windings. The difference between these two windings is due to the difference in arrangement of end connections at the front end of armature. The schematic diagram of wave winding is shown. In wave winding, two conductors in a coil would not lie under the same pole. Referring to the figure, PQRS forms a coil. Conductor PQ is under the north pole, and conductor RS is under the south pole. In this type of winding, there are two paths in parallel, irrespective of the number of poles in the machines. Only two sets of brushes are necessary. But it is usual to fit sets of brushes equal to the number of machine poles. Lap winding. The schematic diagram of lap winding is shown. In lap winding, finishing end of one coil is connected to a commutator segment and to the starting end of the adjacent coil situated under the same pole. Referring to figure, finishing end of coil 1 is connected to commutator segment 2, and coil 2 also starts from commutator segment 2. Both coils 1 and 2 are under the north pole. In this type of windings, the number of parallel paths is equal to the number of machine poles.